Alright, we're going to do the section on linear programming now, and this is one of the best sections in the book. You first need to know a couple of vocabulary words. Constraints just means limitations. I have two pictures here, it's kind of hard to see. This one is bounded, which means there's a line on every side of it. It will have both a maximum and a minimum value. That will make more sense later, but bounded has both. Unbounded has one or the other. The shaded region is what we call the feasible region. The constraints are the lines that form your boundaries, and the vertex is where 2 points or 2 lines cross. Okay, hang on. So in almost all of these problems today, you're going to be asked to optimize something. And optimize means find the best price, the lowest cost, the best profits, whatever. There's 7 steps to do this. The first is you're going to start with a word problem. And you have to define the variables in the word problem. Then you're going to write out the inequalities that form your constraints. Then you're just going to graph and shade those inequalities, and that will give you your feasible region. Then we have to label the vertices. And you can do that by hand, you can do it by logic, or you can use your calculator and figure out where these lines intersect. Once you've done your whole graph, you need to go back to the word problem and write out the function that's going to be optimized. Once you've done that, you create a table, you plug in your vertices, you select the greatest or the least result, whichever it was you're trying to find, and then you answer the question. So let's do one together so you can see what this looks like. Here's the word problem. Each week, Morgan can make between 10 and 25 necklaces and 15 to 40 pairs of earrings. If she earns $3 for each earrings pair and $5 for each necklace, and she has to make at least 30 pieces of jewelry a week, how many of each kind should she make to maximize profit? Define your variables. We always use X and Y, and in this case I said X is going to be the number of necklaces and Y is going to be the number of earrings. And then I set my constraints. X was necklaces. She had to make between 10 and 25 necklaces. So I put necklaces between 10 and 25. If she had to make between 15 and 40 pairs of earrings, so I put earrings, which was Y, between 15 and 40. And then it said she has to make at least 30 pieces of jewelry a week. Well, it could be either X or Y, but when you add them up, it's got to be bigger than or equal to 30. That's what at least means. Equal to or bigger. So I set my constraints. Now I get to graph all that funness. These problems are going to take up a lot of paper. My constraints. Here was X between 10 and 25. I drew a line on 10 and on 25, and I shaded the area between them. Then I did my Y's, 15 and 40, and Y was between them, so I shaded that area. And then that last one, X plus Y was bigger than or equal to 30. Here's the line, and that's shaded above. So this is my feasible region. It is bounded. It will have a maximum and a minimum value, but in this case I'm trying to find the maximum because she wants to maximize profits. I labeled my vertices. And those are the only points you need. We do this whole big picture just to get the points of your vertices. Because now, last page, you make a table. And your table is, you have the points of your vertices, you have the function, and you have the profit. I have to go back to the word problem, and what it said was she earns $5 for a necklace, $3 for a pair of earrings. And when you put that together, that's your profit. So I took all of my points and I plugged them into that equation. 10 and 20, 10 and 20, 15, 15, 15, 15. And I got all of my answers. In this case, the maximum value came at $25.40 when she made the most of both. Surprise, surprise. Maximum profit was $245. So the last thing I had to do was take this point, $25.40, and use it to answer the question. She should make 25 necklaces and 40 pairs of earrings. And we're done!